All right, so I'm doing a new video, so it's better. This is for the assignment Bridge Designer, and it's going to show you how to download the program and design the bridge that you will later be 3D printing. I have a video here from a real structural engineer. He will teach you how bridges work and how the forces are put throughout the bridge. It's a really good one to watch. He even has a suggested way to design your bridge. And then this is the old video, which will be replaced by this video. All right, so the first step is to actually download the program. This will work at home, but not on a Chromebook, just a regular computer. If you have Windows, you'd have to probably search for the installation program for West Point Bridge Builder um, for an Apple computer. But this one will work for regular PCs. So you're going to click on this download button and then install the program. Once you have it installed, in the start menu, you can just type in the word bridge and then you'll find it here. Now, notice that there's one for older computers. Just use the regular one and we'll open up the program here. 2016 was the last year that they actually made this program. It still works just fine though. We can close the tip of the day, or you can keep looking at tips forever. So let's close it. We're going to create a new bridge design, and then you're going to say OK. Uh, Next time you come in and work on your bridge, though, let's say you saved it. The only way to open a bridge after you've saved it is to come in here and open it through here. Some reason, maybe because it's an old program, when you just double click on the file from your browser and your computer, sometimes the computer doesn't know that this is the program to open it with, so just come in and open it this way. But right now we're making a new one. We're going to say OK. Now this is just telling you the responsibilities that you have to make a bridge and stuff, so let's just get next. This is if you have a competition. They don't have the competitions anymore, so we'll hit next. This right here, there's lots of things that you can do. So if you were just doing this as a class, as just a digital assignment, and you weren't going to build the bridge in real life, there's lots of things on here like doing a pier and arch abutments and all these things that we're not going to be able to do with the plastic bridges that we're printing. So we're going to keep it simple. Don't change any of this except for up here. It seems to work best as far as like the ratio of everything to bring the bridge down to 16 meters. Um, that's if you want an odd number of segments, which makes it easier for me to hook on to the middle of the bridge. This it's not a good example, but so yeah, so if you have it in the middle of the bridge, then you can hook onto the middle of the bridge. All right. If you have an odd number of segments, then you have a beam coming right down the middle and have to hook kind of up to the side of it. So this seems to work the best for what we're doing. So 16 meters and then hit next. All right, don't do anything here, just leave it alone. Now you can choose one of these top three ones here. I don't want your bridge to go below the road. Keep everything above, so I can just set it on my bridge breaker and just pull down from the bottom. If we do something like this, then if I set it on, it's now a wedge. So only the top three work for what we're doing. So just pick one of them. You can change the design later. You can turn it into an arch or whatever later, but it's good to have something to start out with. Hit next, and then type in your name, and next. And it tells you the order in which you should do things. Draw the joints, then do the members, test your bridge, strengthen anything that fails, and then minimizing everything that doesn't fail until it almost fails. So you're building this bridge so that everything is going to be equal in strength relative to how much force it gets. We'll talk about that more. Finish. All right, so let's do it. Joints first. Just click those joints. It already defaults to that. Click, click, click. And then switch it to the member tool. This one you have to click and drag. These down here have already been drawn for you. Click and drag, you can do all of the bottom and all of the top in one stroke. It still considers them separate pieces, but it just makes it easier. So again, click and drag, and you just quickly put this together. These are just labels. All right. I'm going to tell you to do something else here as well. Okay, so that's the erase tool. This is the pick tool. You can click and drag and move things around. I'm going to tell you, okay, right here, this gives you more fine details, like where you can place things. So notice how I can move it really in small increments. And then this one right here, there are larger increments. You can also use the arrow keys on your keyboard and just nudge it to change the shape of your bridge. Anyway, when we 3D print this, anything that crosses is going to be connected. So if you make any X's at all, then put a joint, switch to joint, put a joint right in the middle of the X, and then make sure that you have that. So if you have anything crossing another piece, put a joint there, all right? But if you aren't going to have something there, just leave it straight. Okay, there's a couple of things. So there, you can change what it's made out of, but we're not using different types of plastic. So whatever you choose here, make sure the entire bridge is the same. Same thing here. In the real world, you'd make certain pieces solid and certain pieces hollow. With a handheld 3D pen, that's going to be harder to do. So even though it would be more efficient to use a hollow tube for members that are in compression, because you can't do that, we're going to make them all solid. That way it's going to simulate it more realistically as to what we're going to be doing. So it's not going to be the most optimized bridge possible with the way that this program works. So don't worry about the price so much. So yeah, solid bar, just leave it there. This is how big they are. Right now, it just made everything 140 by 140. These two buttons here, these blue ones, if you have a member selected, it'll make it bigger. So now that's a 150 by 150, and this is 140. But if you have two things selected, even if they're both different sizes, if I hit that, it'll make the 150 to a 160 and the 140 to the 150. And I'll just bring them back to what they were. All right, so over here where I am, you have a list of all the pieces that we've made. Now, if you click on this, it's organizing them by which one we made first, and then this is the material type and size. So far, everything's the same, but if we did by length, then it would organize it from shortest to longest, and then we also have the slenderness, which is related to how long it is compared to how big around it is. This number, the slenderness number, can't go over 300. That would mean it's too skinny compared to how long it is. All right, now let's see here. Let's go ahead and test it. I'll move me out of the way. And so there's a picture of a truck. Let's click on the truck, give it some time, it'll pull it up, and there's a truck driving across, and it brakes immediately. That's understandable because we didn't really do anything. This right here these are buttons where you can click and drag, and that moves you as a person. Just kind of turn your head and then move forward and back. This one pans, so you stay the same distance away, but you're just moving up, down, left, right. This one, you stay in the same spot and you just move your head side to side, up and down, and this brings you back to home, and this puts you in the truck, and you can look out and be scared for your life. All right, now, if you don't see those buttons, then maybe you clicked on the use old computer version, or you just need to go back out so you don't see the truck anymore. Click on test and then click on use old style graphics. It always says that. It doesn't toggle between old and new. So you just click on it and see if it makes it better. If it doesn't, then you probably have the old version. Anyway, so you're going to use the button to test the truck, and then the button with the two pencils, the triangle, and the ruler to go back and change things that went wrong. All right, so look here. So compression. So these turned red. These ones right here, these ones right here, these ones on the top. And what's interesting is, I've seen tons of bridges break, and these are places where it normally breaks. So either on the top, and it just kind of smashes together, or on the sides right there, and it smashes on the ends if you don't reinforce those. So when you build your bridge with a pen, you want to make these ones bigger than the rest because they're the ones that experience the most force. Okay, so I'm gonna, oh, they're already clicked. So when I went over here and I just clicked and dragged, and if you need to, it probably looks like this. So you just click on the word compression and it puts it at the bottom, click it again, and it'll organize it from high to low or low to high. And click and drag, and you can select all of them, say, let's make them bigger, boom. So, which is, if you remember the order of things that told us to do, this is what we're doing. Make the ones that break bigger. And it fixed all of them except for one. So let's make that one bigger. So that should be the biggest, thickest piece on your bridge. And let's test the bridge. Voila, it should work. Okay, now notice there's certain pieces that are red and certain pieces that are blue. As the truck goes across, they get more and more red or more and more blue. The red ones are being smashed in compression. The blue ones are being pulled apart in tension. And what you want to do is figure out how to make them all experience the same amount. Like, see how this one right here is kind of getting pink, but this one's getting really red. What if we make the ones that didn't break even smaller so that they're all getting the same close to breaking? Where do we find that number? It's right here in the compression. So you see that 99? That means that this one is 99% of the way to breaking. 95, 93, but we have these ones that are like in the 70s. So if they're in the 90s, let's leave them alone. But if they're under 70, for sure. And now these are all 0, but if you look, they're in tension. So we got to look at those numbers and be careful that we don't pick anything that's like in the 90s on that one. So I'm going to actually pick everything from here down, and I'm going to make them all smaller. Test the bridge and see what happens. And voila, it works. So when you build your bridge in real life, you can make those ones smaller. Can we do them again? Sure we can. That one went up to 89, so let's go from here down. If you hold down Control, not Shift, but Control on your keyboard, you can deselect ones that are already kind of high. This one's in the 80s, so that's pretty close to breaking. 77 is pretty close. Let's see what happens. What is this one? Let's leave it. Let's see what happens. Let's just make them all smaller and try the bridge, see what happens. Do they break? They do not. Cool. All right. Now that one's at 99. Definitely can take that one off. That one off. Notice how it's symmetrical. Okay. 89, 88, mostly symmetrical. 85, 85, 82. Yeah, make everything else smaller. Drive truck, come back, and one of them broke. So I'm going to make that one bigger again. Okay. So you want to get to the point where You want to make these as small as they can go, so that you know when you print the bridge which ones need to be thick and which ones can be thin, and your bridge will still work. Anybody can print a bridge and just make a big brick, and it'll work, but it takes an engineer to design a bridge that where everything is being optimized so that it's using its full potential. And that would be, so now look at this, the numbers go gray. As soon as I click the truck and come back, I don't even have to wait for the truck to pass or fail. And it'll tell me that that one would have broken. So I'll make that one bigger, drive it, come back, and then it redoes the math and figures out that, okay, it won't break now. This one right here in the middle, that's where I'm hooking onto the bridge and pulling on it. So even though this says it can be smaller in real life, this one you're probably going to make bigger than normal, than this says, because that's where I'm loading it. All right. So again, you're just going to go through, and these ones, especially in the 40s and the 30s, those ones will get smaller. Drive the truck, come back. And just you can keep going and optimize this bridge to the point where any smaller and it would just break, which seems counterintuitive. Like, why would I do that? It's because you don't want to, like this 13%, why would you put a ton of steel there if you don't need it? Make it smaller. Of course, there's a limit to how small it can go. There's that slenderness. So if I keep making it smaller, 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 eventually you'll see this kind of turn purplish color here, or pink. That means you went way too small. Okay. But will that still work? Yeah. I went as small as I could, and it still worked. Let me turn my lights. All right. So before you optimize, though, you want to figure out, what do I want my bridge to look like? And that's where you can like move things around. Let's say you want this to be more of an arch bridge, okay? Or you want it to look like, this guy's bridge right here, okay? You can move things around, and it gives you that blue crosshair when you move things, so you can see how it lines up with the other one over here. So use that to try to make sure everything is symmetrical. There, now I have an arch bridge, but of course I made that one super tiny. There you go, now it's smaller. Now if I like added a joint in here, and then I came up like this and made another triangle in there, that would, and just kind of reinforce that like that. That makes these, let's see. Yeah, it's still a long piece, so I need to go back in and make it 2 short pieces. Let me see if this one, yeah, see how I can click on that one and that one. This one's a little bit off. There, now we're more symmetrical. So if you want to make a piece that's really long, shorter, you can, add more to the bridge like that. And you can change things however you want. You can move this up. So you have like a little arch here, and then another arch here. If you look at this bridge, this guy, he has like arches. So you see the red ones going down, and then the blue ones going up. Okay, so he's basically got a whole bunch of arches built into his bridge. But the problem with his bridge, this simulator only likes triangles. So if you look at his bridge, he has some, they're not quite squares, but they're not triangles. So you'll have to kind of modify his bridge to make it work with the simulator. Otherwise, it'll give you an error like this, where if I delete that, now this is a square. And if I try to drive the truck, it says, hey, you got a square. If you have a square in here, it's going to be wobbly like that. So it won't even let you test your bridge And we do have undo and redo here, so there you go. All right, so I'm going to test this one. So now we have, little arch, big arch, and it fails. And so I have to go in here and fix things, make that one bigger, have it come back. That was the only thing that went wrong, but there's probably other things I can make smaller now. Now I've changed everything. I have to re-optimize the bridge. So what I tell students to do is to build two bridges. Build one that's kind of, the standard bridge that they tell you to bridge as that they tell you to build as a practice bridge, and then do another one where you kind of like do your own thing, and then decide, do I want to try to be adventurous and try my own thing, or do one of the designs that are, classics. So to turn this in, what you're going to do is you're going to use the snipping tool. So you can go to snipping tool, and then you say new, and then just draw a big picture, or big box around it. And there I am, weird face right there. All right, and then you're going to click on save right here, and it'll save it in your pictures. And then when you go to Canvas, you can turn it in. What I'm going to be looking for is the fact that you have different size members on there, and you didn't just leave everything at the default 140 by 140. All right. I'll exit out of that. No, I don't need to save that. All right. So I think that's everything you need to know on how to build your bridge. The other thing is how to print it off so you actually can use your pen. You need to go, don't click on the quick print button. You need to go into the menu and click on print in the main menu and file. Okay, so print right there, because this might be set to the wrong printer, and it is right on mine. So I need to change it to the right printer. If you're not my student, then ask your teacher which printer is the right one. For my students, it's this one right here, room 504, and it's the 553. I just clicked on it, and now you got to wait like a good 10 seconds almost for it to realize, okay, I clicked on it. I have students that sit there and just keep clicking and freak out the computer. But just as important, you need to go to page setup and change this to landscape, so that when you print your bridge, it's sideways on the paper and makes it longer. That way we can make bigger bridges. Okay, so landscape for your bridge design, and then you'll hit print. It'll print out on paper, and then you'll be ready to move on to the next video that'll tell you how to actually build your bridge. All right. All right. I'll see you guys later. Have fun designing your bridge.